Maybe we start with a quick recap because, as Xebia already mentioned, this is kind of series that is under umbrella topic towards open data lakehouse architecture. We already previously had episode 1 and episode 2. The first one was a kind of introduction to data lakehouse concepts. Some high-level architecture was deconstructed, and we also touched base on some market trends. Next episode was dedicated to storage. We, together with Tomasz Kostyrka, discussed the topic of open file and open table formats, the evolution of storage from the classic data lake towards data lakehouse architecture. We also dedicated some time about some recent advances in layout optimization that can seriously help you that can help you to seriously boost the performance and also decrease the cost of querying your data. Today is episode number 3. We are going to discuss the metadata catalogs. As a recap, you all know that there are 3 main building blocks of data lakehouse architecture. So it's storage that we already discussed. It is compute that we are going to discuss in the near future. And the third one, I think the most important one, is our data catalogs. So the agenda for today is that we are going to discuss the main concept between data catalogs and architecture, some brief history of evolution of data catalogs. Also, we'll discuss some key features and current trends. But the main part of this webinar will be dedicated to our evaluation of open source data catalogs and how we can evaluate them against the proprietary market leaders. We'll also say a few words of recommendation and next steps. And if time permits, we'll also conclude with two live demos. So what is basically data catalogs? You may, of course, work with some platforms like Snowflake, Databricks, or you may even have some prior experience with Hadoop ecosystems. And always in this architecture was a component that is kind of responsible for kind of navigation and enforcing rules. Navigation meaning that you can somehow prepare an inventory of all your data assets, for example, tables, volumes, machine learning models, you can name it. And plus, you can enforce some rules, some activities on top of this asset. These rules might be related to, for example, security enforcement, but it also may enforce some policies that, for example, will do for you some maintenance task around your data, and also, for example, enable you to share data between catalogs. When we are discussing the data catalog landscape, we can clearly see we can clearly observe that there are some catalogs that are mainly implemented towards business users, so people that are more that would like to know more about the real data content, about the relationship between data, about the data quality, about the basically speaking, they are more towards data oriented. But at the same time, we can also see data catalogs that are more technical or operational, meaning that they are mostly dedicated to topics like security, audit, sharing, maintenance, and things like this. There are, of course, some hybrid solutions. In other words, the many solutions that are available on the market can somehow combine some elements of both operational and business catalog in a one product. We, of course, observe proprietary paid options that are available, that are part, for example, of the cloud data platforms like Unity Catalog in Databricks, some third-party data catalogs that you can connect to to any of your data platforms. But there are also, for a year or two now, evolving a few very promising open source alternatives. And also the goal of today's presentation is somehow to present them, introduce them, and also somehow compare them against our well-known proprietary offering. Some of the open source catalogs are also dually licensed. So there are like open source, fully open source version available under Apache license, but there are also some cloud managed version available as well. So we also highlight that. And finally, there are standalone and built-in data catalogs. Standalone meaning that you can use them as a separate component, and that you can combine with other open source tooling. But there are also some, especially proprietary ones, that are very heavily connected to the rest of the platform. So you cannot really use them separately, but you can use it for integration with some existing open source component. So data catalog is a kind of layer between like workloads, users, and lakehouse storage data. So somehow a layer that can help you to navigate and enforce some rules for your data. If we take a look at the evolution of data catalogs, we can for a moment come back to the old times of Hadoop data lake, Hadoop ecosystem. So at that point of time, the situation was pretty much clear. So we got like three components that were most responsible for data governance, data security, and metadata. That was Apache Ranger, that primarily was used as a kind of access control application that was mainly for enforcing security. It was capable of also some column masking and row masking. It has built-in audit logs. But the main drawback of this solution was that it was mostly tightly coupled with Hive warehouse, data warehousing solution. So later on, there was some option also of integration with other popular distributed query engines, like, for example, Trino or Apache Spark, but the integration was not that good as for the Hive Metastore, for the Hive data warehouse. The next component was this Hive Metastore. That was, as the name suggests, like a component was only responsible for holding and serving the tables and table partition metadata, some information, of course, about schema, location. There was a very simple component that was a kind of like a layer between the HDFS storage and your query engines. And finally, there was an Atlas. There was Atlas component, Apache Atlas component that was primarily responsible for capturing lineage, glossary classification, but at the same time, it was also a source for ABAC, or like so attribute-based access control or tag-based access control that can be paired up with Apache Ranger. That was the history, but nowadays the situation looks pretty much different. So we no longer have only like one component, one option for all these like three features. So we have a multiple data catalogs available. Plus, we can observe that right now the data catalogs, as I already mentioned, can be more or less categorized as either technical or operational. That was mainly for these like things like security, metadata management, policy enforcement, and credential binding, and business catalogs that are more towards more oriented around data, around properties of data, metadata, and stuff like this. Also, along the way, the security mechanism changed a lot, because in the Hadoop ecosystem, we are mostly relied on Kerberos ecosystem. So we relied on Kerberos tickets, and there was a separate steps and separate entities involved in generating tickets and delegation tokens, and also enforcing the policies. Nowadays, the architecture is, in my opinion, much more clear, much more streamlined. So right now, in the Lakehouse architectures, we are mostly relying on open ID connectivity. And right now, the data catalogs are mostly responsible for enforcing and checking the policies. So either they are role-based access control or attribute access control. And they are communicating with some third-party systems to obtain scoped credentials for end emails. We will dig into in a moment. So if we take a closer look at modern catalog features, the list of the features that data catalogs right now have to offer is pretty much very long. So of course we have still some metadata around tables. Right now, it's the standard is Iceberg catalog, since the Iceberg is right now, at least in the open source, where the predominant open table format that we covered during the episode number 2. Also, there is also a shift in entities that are inventorized by data catalog. So in the past, it was purely around tables, or even so Hive tables. But right now, it's more about multimodality. So it's no longer only tables, but it can be volumes, it can be machine learning models, it can be some Kafka topics. So it's much broader. Right now, also as I mentioned, data catalogs took over the access control. So it's no longer that there are some separate component like rangers that are solely dedicated to granting access. Of course, rangers still can be integrated with some of the open source data catalog as the source of security, but right now it's the data catalog that really enforces the security policy. The biggest shift is that right now data catalog is supposed to support heterogeneous query engines. So it's not longer only Hive or Hive plus Spark or Tino. You can right now have any single node or a distributed query engine that speaks or is able to communicate over Iceberg REST API that can be used for integration data catalog. Also, the lineage is right now de facto standard, and there are a couple of options for collecting image, but open lineage seems to be one of the most popular one, and many data catalogs around the world right now have a first-class support for open lineage protocol. There are some new concepts that were introduced to business data catalogs, like, for example, data contracts assertions. It's because of this new data mesh architecture that data catalogs try to also help to support some way, for example, with options for defining the data contracts of the data products that are shared in the data mesh architecture, with some helper methods for assessing whether the contracts premises are met. Of course, data profiling, data quality, because right now we are heavily relying on either Iceberg or Delta or Hoodie tables. Table maintenance is something. So table maintenance means, like, for example, vacuuming, compaction, or like deletion of some old content is something that it should be also covered. Right now, as we in data world, and not only, we are strongly advocates of ops manifesto, ops movement. Here we also observe that many, especially the proprietary catalog, support configuration management as a code. Also, the integration with IDPs is automated, like with SCIM protocols, SCM methods. We are also observing that more and more data catalogs support model context protocol. So it's the component that is the server that is responsible of bridging your agents or LLMs and your different source of data, like, for example, catalog or databases. And finally, data sharing. So because you already mentioned some of the features, now I would like to briefly discuss you. So you are familiar. So you get familiar with what's happening behind the scenes. So one of these new features that are part of the technical data catalog is the credential binding mechanism. So basically speaking, the credential binding mechanism is the mechanism that allows end users to access the tables, the content of the tables that are stored on object storage uh, without having the credentials for the object storage itself. So instead of having like a user and password or some other ways of other ways of authentication against your object storage, you just like talk to your data catalog, and data catalog is responsible for and getting for you a down scope or limited for a specific path on the object storage credentials that are sent to you that you can use for a limited period of time, like for example 1 hour or something, for accessing your object storage. So in other words, you don't need to have any credential for your object storage, but your data catalog is responsible for, after assessing your credentials, your roles that are assigned to you, can decide whether it should allow you to access a specific part on your object storage, and it contacts the token service for generating time limited and also scope token that allows you to access the data. So you can see on this diagram how this flow pretty much look like. Next thing that is becoming the standard in data catalogs is the support for MCP, so Model Context Protocol. So Model Context Protocol is an open source standard that allows you to connect a different, as I said, LLM on GenAI powered systems to your data sources, and that can be data sources like databases, catalogs, but it also can be some tools. So it is standardized access to outer world you may saw for GenAI systems. So you can imagine a situation, and you may also ask a question: why is it important that data catalog should support MCP? So you can imagine that you are an analytics engineer, that you would like to develop a kind of data transformation, and there are two, and you would like to get some support for your AI engine, like Cloud, Codex, or Gemini, for example. And in order to make this agents operational, you need to connect them to both, like table definition, lineage, views, and stuff like this. This is why you need to MCP server for your data catalog. And then the third time, you need to make them use your standard tooling. So for example, in case of analytics engineering, it can be dbt. So if you got these two things in place, then you can just prepare a specification for your transformation, and connect these two MCP servers to your AI engine configuration, configure to access to this MCP server. And by doing so, your engine is able to communicate with Data Hub, run some queries, got some additional information on your data assets, and at the same time, while developing, for example, dbt pipelines, and can easily call dbt for testing, for generating some code, for running some, for example, syntax checks or something like this. So this is really this is becoming really crucial to make your data analyst or data analytics engineers or data engineers more productive. Next is the open lineage, because open lineage is right now de facto standard. So in our companies or organization, it's very important that you have a clear understanding how your data sets are generated, and what are the relationships between data set. This is why open lineage, very similar to MCP, is a kind of open standard that makes it possible for your tools to generate metadata that can be easily ingested, can be easily captured by data catalogs, like for example Data Hub or Open Metadata. By doing so, you are no matter what tools you are using, the lineage information is captured and preserved. So it's a great option, because right now it's becoming standardized, the way how you emit the events related to open lineage. And by the way, also we as Xebia Data, previously Getting Data, we are strongly involved in development of this standard. During the demo, I will show you, for example, the column lineage for Apache Spark, and this is something that we contributed to the open lineage community. Finally, you may ask the question, what really makes a data catalog and open data lakehouse architecture? And the answer is not that straightforward as you may think, because in our opinion, there are actually two options of being open in the context of data catalogs. Of course, the most straightforward answer is that the data catalogs is distributed under open source license, like Apache license, for example. But it's not. But it's only half of the truth. We also think that the other definition of openness in the open data lakehouse is when data catalogs, also the proprietary ones, are supporting the open standard. Like, for example, Iceberg data catalog, open lineage, open data contract standards. When they allow some open source tools like Trino, Spark, DuckDB, Polars to connect to data catalog and also access the data assets that are protected and cataloged by this service, and also at the level of data itself, also the support for heterogeneous table formats is something that makes even a proprietary catalog, like for example Unity catalog from Databricks, and open data catalogs in this sense. This is why we distinguish like open by design, so meaning that the catalog is adhering to some open standards like open lineage, open data contracts, Iceberg data catalog, or can be also licensed under open source permissive licenses. And if we take a look at the data catalog landscape, we can somehow place many of the available solutions, but that either on this more technical operational side, like for example Apache Gravitino, Nesty, Lakekeeper, Polaris catalog, CalcMetaStore, or more on the business side, like Altan, Colibra, Amundsen, Open Metadata. And of course, there are some that in the middle of this continuum that have some both technical and business features available. So let me now allow Radek speak a bit more about open by design data catalogs.
Yeah, thank you, Marek. I hope that you hear me well. Okay, my name is Radek, and I would like to present you some examples of many different data catalogs. And in general, we will focus primarily on operational data catalogs, but some of them will have more features and will be also considered as classical data governance technology. We divided our examples into two groups. The first one will be open by design data catalogs, and the second one will be classical open source technology. And so we will present selected technology during a demo at the end of our webinar. So let's wait for that. And let's start with the first group. I will check if I'm able to. Sorry, Mark, I'm not able to switch.
Okay, I can do it for you.
Okay, now I hope that now it will be.
Let's give it a try.
Okay, sound check.
Yes, it works.
Okay, now it's working. Okay, thank you. Okay, let's start from our first example, Databricks Unity Catalog. This is one of the most popular and recognizable data catalog on the market. This catalog is created by a company called Databricks. I hope that you should be familiar with this company because this company is responsible for creating free really popular data technology, Apache Spark, MLflow, and of course Delta Lake, which is used as a data table format in many lakehouse platforms. And also this company created their own data platform available to use on AWS, GCP, and Azure. And the heart of this platform is Unity Catalog. Unity Catalog is used to catalog all of your data in a Databricks platform, structured data, unstructured data, business metrics, or even AI models using open data formats. Of course, the main primary data format is Delta because it was created by Databricks. But a few weeks ago, they announced that they will be supporting also managed Iceberg tables. So you can use Iceberg, you can use also external Hoodie tables, Parquet, or more. You can also connect to Unity Catalog to using their own Unity API, but also Databricks Unity Catalog has something called Uniform, and this feature is used to generate additional metadata for already created Delta tables. And with this feature, you can connect to Unity using Iceberg REST API endpoint, and you can query Delta tables using this Iceberg metadata as they look like Iceberg tables for our open source clients. So if you have some technology that this technology is able to only connect to Iceberg tables, it's also possible using Uniform to connect to Delta tables using this Iceberg REST API. And of course, they are supporting also classical Hive Metastore API. They have also plenty of other features like automated lineage, data monitoring, access controls, auditing access, query federation to other lakehouses catalogs, the data sharing with usage of open standard called Delta sharing, AI-powered documentation, and many more. The Unity Catalog is also treated, recognized, considered as reference catalog for other catalogs. So if we will compare many catalogs together, Unity will be the reference catalog for us in our comparison matrix table. Okay, the next example is Snowflake Lakehouse. And in Snowflake Lakehouse, you can find two different catalogs. The first catalog is Horizon, and this is internal Snowflake catalog. So this catalog is used to catalog and govern internal Snowflake dataset, I mean mostly Snowflake native tables, but also something called managed Iceberg tables. So you can control and govern and catalog your Iceberg tables on your external data storage from AWS, Google Cloud, or Microsoft Azure. But this internal Horizon catalog does not have Iceberg REST API endpoint. So if you would like to, like you can see on the slide, if you would like to connect Apache Flink, Apache Spark, PyIceberg, Trino to such Iceberg tables managed by Snowflake platform, you should use additional data catalog called Open Data Catalog, Snowflake Open Data Catalog. And this catalog is in general managed Apache Polaris catalog. So this catalog is based on open source technology, and it is managed service available in Snowflake platform. And this technology is used to give ability to connect from external tools, mostly open source technology. And you can see on the diagram that you can sync these catalogs together. So you can create internal managed Apache Iceberg tables in Horizon catalog and sync them to external data catalog, or even you can create external managed Iceberg catalogs and sync them into Horizon catalog. So this is bidirectional synchronization. Okay, now let's see what is able to use from major cloud providers, I mean AWS, GCP, and Microsoft platform. Let's start from AWS. If you are familiar with these clouds, you can have this knowledge that the main data catalog in AWS is something called AWS Glue Data Catalog. And for many years, Glue Data Catalog was used as Hive, classical Hive metastore. But nowadays, you can use Glue Data Catalog to catalog your iceberg tables, hoodie tables, delta tables, and many others formats. For example, it can be also used as Kafka catalog. So you can share also your metadata from Kafka. And if you would like to extend possibilities of this operational catalog called Glue Data Catalog, you can use also AWS Lake Formation and Amazon Data Zone as government tool. And you can also see on the diagram that Amazon is working on something called Amazon SageMaker Lakehouse. This will be unified Lakehouse Studio for whole Lakehouse possibilities available in AWS platform. The next player will be okay, no, sorry. The next player will be Google, and Google has also their own new service called the Big Lake Metastore. In general, Big Lake is a new technology available in Google Cloud to connect to Iceberg, Delta, and other popular open source formats from Google technology like BigQuery, but also this is able to use this Metastore, Big Lake Metastore with technology like Trino, Flink, Spark. So it is also opened by a design example of data catalog. And of course, with strong integration with Databricks, the main data governance tool from Google platform. And then last but not least platform is Microsoft Fabric. This is also a new kit on the market because this is new technology created by Microsoft. And in Fabric, you can find something called One Lake, and One Lake have its own catalog called One Lake Catalog. So if you would like to catalog your mostly Delta tables, but they're also announcing that they will be supporting iceberg tables, the One Lake catalog is the best choice to use to catalog your Delta and iceberg tables. And to use some government possibilities, there is a well-known Microsoft Purview unified catalog and governance technology ready to use on Fabric platform. Now let's move to another group, open source data catalogs. And I will start from Unity Catalog. But this Unity Catalog is open source alternative technology. And it is really important to notice that Databricks Unity from Databricks platform is cloud source, and Unity Catalog is open source technology. And there are two different kind of products. The Unity Catalog available in Databricks market is not managed version of open source Unity Catalog, but there are two different separated products. This is really important to notice. And in general, Unity Catalog open source version is also created by Databricks. It is available in GitHub repository under Apache license. It has also support for multi-format, Delta, Iceberg, Hoodie. They have internal access control, open specification, Unity API, Iceberg API, Hive Metastore, and so on. And in general, this project is divided into three modules. The first module is Unity Catalog Server. The second module is Client SDK. And the last one is there are connectors mostly for Spark, but are coming more. And you can manage this catalog using their own UI and command line interface. But to be honest, the speed of adding new feature is really slow in this project. So if you look at the repo on the GitHub for example, if you look about commits in the last year, you can see that there are only a few commits in the last year. So development of this technology is rather slow, and there is still limited functionality in this open source version. So please remember that this is another kind of project. This is not the same you can find in Databricks platform. Okay, the next example is Apache Polaris. I already mentioned about Open Data Catalog. So Open Data Catalog in Snowflake is managed version of this Apache Polaris data catalog. And this is open source data catalog with support for Apache Iceberg REST protocol. And generally, it was internally created by Snowflake and donated to Apache Software Foundation in last year. And it was created to give ability to connect to Snowflake lakehouses from open source technology, but they have also this concept of internal and external catalogs. So this technology was created to sync catalogs between them. So this is the main pros to use this catalog, this internal external catalog providers. But to be honest, if you are using the open source version of Polaris, there is no UI to manage this Polaris. You can use, of course, a management API, but there is no UI. You can find UI, but only in this managed Snowflake version. So the open source version has no user interface for managing and seeing what is happening inside this catalog.
Okay. Next competitor, next product that is available that is pretty novel is a Lakekeeper. Lakekeeper is a purely technical data catalog with the Iceberg catalog support and access control. In opposition to other presented technologies, it's written in Rust. It's implemented in Rust. It's very lightweight, so you don't. When it compared to, like, for example, Polaris or Apache Gravitino, it's really pretty lightweight. It supports credential binding across many object storage. It has a very solid documentation with working example. It has a UI. It does have a UI. It may appear a bit minimalist, but it's really functional. So you can really manage the catalog with this UI. There's an excellent Docker playground. So if you would like to start experimenting with Lakekeeper, you can take a look at their examples and Docker Compose provided. It already provides you with a fully featured environment with IDP like Keycloak, with configured query engines like Trino, Iceberg, PyIceberg, or Spark, so you can straight away test there. On the con side is that there is no CLI or SDK yet, so you need to manage it making REST APIs, or of course using the UI. But it's, in our opinion, it's a strong disadvantage because you cannot really manage this catalog without developing something for automation. And it may appear quite limited at first because it has no support for volumes, lineage, or CLI. But exactly, it does what it promised. So if you would like to have a solely table-oriented data catalog, and you would like, for example, connect you with some open source data catalog like Data Hub or Metadata, Lakekeeper is something that you can give a try. Because it's really lightweight and it's really straightforward to deploy. Apache Gravitino. This is something. This is the product or project that is also mostly technical data catalog, but it has some greater support for other entities, not only tables, but it supports models, Kafka topics, Hive tables, or databases, so you can unify the management of metadata across your data landscape. It also, of course, has access control, credential vending. That's de facto standard for all the data catalogs, technical data catalogs presented here. It has some limited lineage support. It has been recently added, of course, using Open Lineage, and recently there was added some integration with Marquez. But the real problem with Gravitino is that it has a very non-intuitive and incomplete documentation. So in order to really deploy it or test it, you need to sometimes really dig into the source code, because the documentation is incomplete, sometimes misleading, sometimes some features are not even discussed in the documentation. You need to really check the source code. Also, the UI that is provided is not very intuitive, and most of the things you still need to, for example, around checking the security or creating a security rules, policies, you need to do it with SDK or CLI. And so this may be a problem initially. So we are still like internally evaluating more in depth this project, because it seems very promising. So our impression is that it has a really broad feature set. One compared, for example, to Lakekeeper or open source Unity catalog. But because of these problems with the very poor documentation quality, and also some minor bugs here and there. For example, recently I discovered a bug with all support for CLI. This altogether makes it really hard to evaluate it fully. But in our opinion, it's one of the best open source technical data catalogs. And also, for example, it has support for MCP that was recently added. Data Hub, that's something that maybe not very, very intuitive at first sight, because Data Hub is mostly considered as business-oriented business data catalog. But this year it also added support for Iceberg Catalog REST API and access control. So right now, to some extent, it's possible also to use it as a kind of replacement for like a full-fledged Iceberg data catalog like Lakekeeper, Gravitino, or Unity catalog. But still, you need to consider is a kind of some extra feature. But because in our assessment, it's not still like a fully functional, because, for example, it's only limited to AWS S3. You cannot use any other storage, including mini IO for easily for integrating with the credential vending mechanism. Also, the setup is not trivial, because it requires both Kafka, Elasticsearch, and also you must be aware of the substantial difference between the open source version and the cloud version. So many of the enterprise grade features like data contract assertion, some approval workflows for data sets, monitoring on notification, not everything is available in the open source version. So in such situation, you need to also consider the cloud paid version as well. So on the pro side, the data discovery limits and integration with many sources, but on the cons, it's still the support for text catalog feature are limited. Okay, so let's conclude this with our evaluation. So here are our evaluation criteria. So our idea was to treat data Unity catalog as a kind of baseline for the assessment. So we do believe that from the technical perspective, it's one of the best data catalogs available. When it comes to business features like business interface for business users, it's not that great. But still, in this comparison, we are mostly focusing on this technical aspect. So we focus only on open source product because they are many customers are asking about some advice in this matter. And we also added Data Hub because it's open source and also has some features related to data technical data catalog. Here are some features that we really evaluated, and we came up with such a comparison matrix. I wouldn't like to go it one by one or say by say, But you can clearly see that some basic stuff around like access control, like iceberg catalog APIs, they are mostly there. Credential binding, support for tables, they are mostly there. But when you assess them like a production or enterprise grade features, like for example, access audit, like for example, integration with SCIM, so like a mechanism for syncing users and groups, like management, configuration management as a code, or like a maintenance, automatic maintenance of tables, or data sharing. There are features that are still mostly missing. So our conclusions and recommendation would be that, as I already started to discuss it. So if you are in need of really like a basic technical catalog with table metadata support, so compatible with Iceberg data catalog, access control for tables, credential waiving, and of course authentication authorization for the services for the REST APIs and UI. This is mostly there. So like most of the data catalogs, technical data catalogs have decent support for that. But at the same time, if you are looking for some production grade features like access audit, automatic user group membership synchronization, management with the code, sharing, some maintenance, some available out of the box, they are mostly missing. So you cannot like really assume that out of the box something like this is supported. So if you were to recommend you something or like some project that you should observe, I think that right now the Apache Gravitino LA Keeper are the most promising one. Why? Because as I said, Gravitino is in our opinion is feature rich. It's developing quickly, but on the like concept that is still not very well tested and documented. There are serious gaps in the documentation that are preventing end users for like smoothly up and getting and this service up and running. And also there are a lot of confusion, what is supported, what is not supported. We actually end up in these projects using an AI coding agent like Claude to really analyze the code to check whether something is supported or not supported. But no, by any means, it shouldn't be the way you like use your product. You need to like read your source code. Lightkeeper, on the other hand, is much simpler, much more limited, but at the same time, it's like really stable, really doing the job. So if you would like to have something lightweight, it's something that, and also these two projects are really like evolving very quickly. So there are no like there are no supported by like a single large vendor. So they are not like heavily impacting the roadmap. So you may expect that this two should be in the near future the most popular ones. Apache Polaris is also an actively developed, but because with this like a direct integration with Snowflake, we may expect that some of the features may be not implemented. Like for example, user interface. Right now, it's because it's strongly integrated, the managed version of the Snowflake ecosystem. There is no interest right now in developing like a standalone user interface. And the Serenity catalog is something really that is not clear what is the status of this project, because the PR activity is very low. We review the commits from the pull request merge from the past half year, and there is mostly housekeeping, like changes to the documentation, some like bumping versions, some really minor stuff. So there is no like a very heavy development around that. So we are also not sure about the future of this project. Bottom line. So we do think that if you would like to have like a fully featured like a data catalog service, you need to, at the moment, of course, in the open source world, to combine some of the open source technical catalogs, like for example, Gravitino or Lakekeeper, and combine it with some like open source or not open source business catalog, like for example, Data Hub. But you need to be anyway, if you'd like to deploy it at scale, you need to be prepared for building custom automations, custom integrations. So all these things that we already highlighted related to production grade support for many things not still not missing. Some of them are on the roadmap. Some then are in the plans. If you take a look at the tickets or discussions, but it's nothing is you cannot take it for granted. Also, the features like, for example, high availability, since now data catalog that is now technical data catalog that is managing, controlling the access to your data assets is of course, crucial element of your data architecture. So you need to take that into account, that you need to, there are, of course, like a hidden charge for deploying these services, but you need to, of course, for example, take care of database backups, database availability, high availability, and stuff like this. And final word is that as we presented here, like two definitions of openness when it comes to data catalogs, you can also seize the opportunity of using the proprietary one, like for example the Unity catalog, and trying, for example, integrate it with some open source query engines, which is becoming slowly, but still possible. The same in the case, for example, of Snowflake. So thanks to Polaris, Apache Polaris projects, the managed version, it's possible to use your query engines that are not the ones that are provided by the data platform. So this is it about the evaluation. We are, of course, happy to hear your feedback and your questions, but let's now maybe quickly turn to demos. It won't take long, but we just wanted to demonstrate that some of the features that we were talking about are really available. So in my demo, I would like to show you very, very, very simple architecture when we have like a Lakekeeper as our technical data catalog, and Data Hub as our business catalog. And I would like to show you how you can, and in this setup, it's connected with IDP. In this case, it's Keycloak, and I will try to show you how you can access these things with two popular query engines. So one is the pure Python based on PyIceberg, and also Spark. So here we have we have a notebook. First of all, we are doing some configuration. Of course, we will share the notebooks after the session. So we are, of course, configuring a few variables. Right now, we are authenticating. So we are authenticating as a user, not as a service account. So we are authenticating against our Keycloak. We can take a look at the token that we got. We can quickly decode it and see that it was really authenticated as an user. My name is Peter Court, and I'm the right user. Right now, I'm connecting to Lakekeeper catalog with this access token. And then I can run a series of commands. So I can try to create a namespace. I can try to write the arrow data frame save it as a table. So we are using just PyIceberg integration. So we are just overwriting the table. We can load it back from the object storage. Here in our example is mini.io. At the same time, we also can use Spark as yet another query engine here. We are connecting to the same Lakekeeper. We can also create namespaces and route some basic ELT pipeline. So we are reading a table from the bronze layer of our Lakehouse architecture, and we can write it back as in the silver layer by doing some tribal transformations. We can now switch back to our data catalog. So we can see that we have already ingested our tables here. It's done automatically. This one is from our silver layer. and we can take a look at our lineage information. So in our case, it's very simple. So we have like tables with 3 columns as in the bronze layer, tables with 3 columns, but with some transformation in between in the silver layer. And here we can also observe column level lineage. By the way, this is something what I mentioned was contributed by getting data. Okay, Radek, I stop sharing now. That was actually this more on this openness by license, that what we called, and now Radek will show you this openness by design case.
Yes, but someone need to allow me to present.
Radek, I just
Okay. I see. Thank you. Thank you. Okay. This will be a short demo using this Open by Design data catalog. And my focus will be on Databix Unity catalog, this commercial version from Databix platform, and Open Data catalog and Horizon catalog from Snowflake Lakehouse. Let's start from Databix. You can see that I'm logged into my Databix account. This is GCP edition. You can use Databix on top of AWS GCP or Microsoft Azure, Snowflake 2. Or they are also supporting all 3 major providers, so I will be using GCP version. And you can see that in my Unity catalog, on the left side, I have my menu called catalog. You can see that I have a catalog called Radek. This is my name. And inside this catalog, I have one database called default. This is really default name for default database, and I have no tables inside. So I will show you also my Google Cloud Storage under this Unity catalog, and you can see that I have I have my GCP bucket, and this bucket is empty. And now I will run a simple query. You can see this query now. To create some simple table, and I will be using from samples database table called customer. I will copy this table to my catalog. So I'm running these few queries. Let's wait few seconds to start serverless warehouse. It is about few seconds to restart such serverless warehouse. Okay, and now it is done. So my queries are completed, and you can see on the left side that I have my table called customers, and I copied 10,000 rows. So you can see that this table is available to query. But now this table is only a delta table. So when I look at my parameters, I can see that this table is delta table. So if I try to query this table using, for example, PyIceberg client, I have information that table does not exist because this table is only data tables and I'm using PyIceberg client. So I need to run additional code to generate additional metadata for Iceberg table using Unity feature called uniform. So I'm running another set of queries. And you can see in these queries that I'm in general setting some parameters allowing or asking Unity to generate additional metadata. And now you can see that I'm added 3 parameters to these tables. And now when I will try again to query this table using iceberg code, you can see that it's starting and it's in general working. My code connect to Iceberg REST API endpoint from Unity catalog, and I can see that I have customer table, and I can see first 10 rows from my table. And when I look into my bucket, refreshing, okay, now you can see that this is my table, and I have two sets of metadata, delta log catalog for delta metadata, and metadata catalog for iceberg metadata. And of course, inside this catalog, I have also Parquet file, and my data is in this single Parquet file.
One comment, brother, please go on.
Yeah,
If you are interested in this like topics of table formats and like comparison of that, you can watch our episode number 2 when we discuss that in details very deeply at the Parquet level. We really discuss now how it's constructed and also how the metadata are generated.
Yeah, exactly. I'm recommending to see. And on the Databricks documentation, you can see table where they put multiple open source technology, and you have information if this technology is supporting Unity native REST API or only Iceberg REST API. So if you are using, for example, Snowflake, you can use this endpoint to query your data from Unity using Snowflake, or if you are using PyIceberg, it is also possible to use this endpoint. If you are planning to use, for example, Freelink or Trino, it's also they have also support only for Iceberg REST catalog. So it is the only one single way to use these tables using this open source technology. Another example is my Snowflake Lakehouse. You can see that I have a lot of accounts inside this my Snowflake organization, and I have something called Open Catalog Instance. I have two instances, AWS and GCP. I will be using also this the same GCP account, another bucket, but the same project. So I will be using this Open Catalog GCP version. So this is the main user interface from Open Data Catalog. This is managed Polaris with additional manage UI, and you can see that I have my Radek catalog, and inside this Radek catalog I have example namespace. I can easily delete this namespace. Okay, remove. Now I have empty catalog, and this catalog is also based on my GCP account. This is another bucket called Radek Polaris, and you can see that this bucket is also empty. So now I will use another code. My script create example table in catalog. This is also Python script with PyIceberg, but in this script I'm creating fake iceberg tables with 10 rows. So this is just some fake random data inside this table. And I have information that namespace was created, and now I'm creating table and inserting 10 rows. I'm going back to my iceberg catalog, refreshing this catalog. Okay, now I have my namespace, and inside this namespace I have my table, and I can look at my bucket. You can see that in my bucket I have my namespace, example namespace, and inside this namespace I have example users table, and in this table, in this folder, I have my data, also Parquet files, and also metadata folder for iceberg metadata. But now this definition of this table is only in open data catalog from Snowflake, but now I will sync this table to my Snowflake internal catalog called Horizon, and you can sync whole catalog, whole database, or just only a single table. So I will sync only this one single table. So I created a new database called Polaris, but this database is empty. So now I'm creating iceberg table inside my Snowflake Horizon database, but it's not a new managed table, but it's only information about external integration from my catalog integration. So before that, I needed to set up integration between two catalogs. It is pretty straightforward, and now I'm creating a link to my iceberg table, and now after refreshing Horizon, I can see that in Horizon I have already example users table, and I can just easily query this table using my Snowflake warehouse. As you can see, I see my data, and also I can connect to this table using my Python script. And please look that this is exactly the same script, read table from catalog, but I'm using different configuration. So I can use the same code to connect to Databricks Unity catalog and the same code to connect to Snowflake Open Data catalog. I'm running this script. And my PyIceberg library fetch me this data with first 10 rows. So it is working correctly. My table is available in Open Data catalog and also internal Horizon Snowflake catalog. Okay, that's all.
Now, this is a great example, how really even a proprietary or managed data platform like Databricks or Snowflake can be easily queried using external, your own query engines, and it's actually working in both directions. You can read and write, and it's really great for that we can use it like as any open data platform. So you not only can use it use your open source components to build an open data lakehouse, but even if you are on managed proprietary data platform like Big Snowflake, still you can adopt this open data lakehouse principle and query it from external tools. Thanks.